Good morning, ladies and gentlemen. My name is Grockowski, and I'm very happy to see you logged to this event. For a long time, I've dreamed about hearing about PREMIS metadata standard from the source itself. And now my dream come true. Such an outstanding presenters we have today. As the event is hosted by the Ifla, let me introduce to you Mr. Tomasz Grockowski, the director of the Ifla Preservation and Conservation Center for Digital Preservation. Thomas, the floor is yours.
And I'm really happy that almost exactly a year after the event was planned to happen, we are meeting. We were supposed to meet in person in Warsaw for around probably 30 people who could come here from Poland and Central Europe, hopefully. And then the pandemics hit us. So a year later, we are meeting. Everyone in her own country. And that is Karin from Sweden, Micky from Germany, and Eld from Denmark, Darek Paradowski, and myself, Tomasz Grockowski from Warsaw, Poland. I don't think that I can add much to the information about the speakers, because anyone who has basic knowledge of the metadata might have had a chance of meeting them or their works all over the place. So the three members of the PREMIS editorial committee are going to speak on PREMIS. And I hope that right now Karin will take the floor.
I most certainly will try to, and also
welcome.
Thank you. And I will start with stealing the screen. I have a screen. Morning and welcome everybody. Yeah, you heard it's me, Karin Bredenberg. We have Eld, Zierau and Micky Lindlar going to guide you through this rather intense day. And what we will do is have an introduction tutorial where we introduce PREMIS to you. And the goal is to give you a baseline of common understanding. I know it's going to be rather intense. You're going to be angry at us at the end because we are really wanting to give you all the things we can in the time we have. So you will get an introduction to the PREMIS community. We will answer questions. You have gotten the link to a Google Doc, but you can also use the Q&A box for asking questions. And we will try to incorporate the answers, or we have a chunk of time in the end, hopefully, where we will live respond to the questions, or we will actually write the responses in the shared Google Doc. So this is going to be the tricky one. Well, you heard about us three coming from the PREMIS editorial committee. We don't have any ways of showing hands or anything in this kind of webinar, but what I'm trying to achieve with this question is actually we are trying to reach out to everybody, even if you have heard of PREMIS before or not, even if you don't know the PREMIS data model, which you will know by the end of the day. And if you are a user of PREMIS already, or if you're not, have you looked at environments? You will soon, in a couple of hours, know what we mean with an environment. And also where you're from. These 4 suggestions, where something else can be really something else, are setting the stage for today. We have an agenda. We will most certainly keep the most important one, noon, for a 30 minutes lunch. Otherwise, the big focus will be the introduction to PREMIS and the data dictionary. And that will be, we will have some short breaks where needed, and make sure that you don't get too stuffed at the whole time. But let's get started. So first we need to have some sort of background. Why are we doing this? Why are we even if I heard some people have waited for this for a long time. And what is this digital preservation metadata? Well, we know the books, the printed books. That was kind of easy. I would say it's not easy when you have to take care of them, but it's kind of all is in one place. You have the book and it has all its information. When we come to the digital preservation metadata, we need to have that as well. Think about the physical book. Even the digital objects must be self-descriptive. We need to know about them to be able to handle them, because these digital objects, as well as the physical objects, needs to be around for a long time, and even longer than that. And what you often do, you need to have something showing this information in some way of human readable way and machine readable. And you will see all the different versions available today. And often what you do is you need to keep all these files together, and then you use the information package coming from the OAS reference model. And as I already hinted, we can describe all the different types of digital objects. It can be born digital, as most of the things are today, or it can be something that gets digitized. So we have the book, we scan it, and what do we need to do with the files we have created then? Of course, we need to make them also live forever, as long as the physical copy. When we talk about digital preservation, Priscilla Kaplan, a long time ago, in the beginning of this century, drew this pyramid. In the pyramid, we can see what we need to know and what the preservation goals are. We have the things needs to be available. They need to have an identity. It's easier when we have the book, but we need the same for a digital object. We need to understand it. It needs to be have a fixity. We need to know that it's still the same object. It needs to be viable. We need to be able to render it so we can see it, and it needs to be authenticated. On the left, you see the means and ways of doing that. So we know what we are capturing. We need to have the description. We need some documentation. We need the secure storage. We all know about those floppy disks. Might be seen secure a long time ago, but yeah, we need to take care of them now and actually make them even more secure. We need to be able to handle the media, so we actually know what we're doing on, what's going on with them. And we need to have strategies for the format. I think we all remember Word documents being 25 years old. Can we read them today? I can give you the hint, no, we can't, unless we have taken care of them. And we need to be able to prove with authentication that it's still the same object, even if we have changed the format. So that's why we need to do it. Then what is PREMIS? Well, it's an international de facto standard it's describing the digital preservation metadata you need. And if you see, the acronym is created from preservation metadata implementation strategies. It's a group of international team of experts who has created it. It's been implemented in different digital preservation projects around the world. And I can say the list, even if we have a list, the list is longer, because it gets sneaked in because everybody realized that we need it. So you can find it in commercial and open source digital preservation tools and systems, but they may not always say that it's there, but trust me, it is. The PREMIS standard, which we'll be going through thoroughly for you today, we have the data dictionary. We have the first number being a major release, so we are up on version 3. We have an XML schema to it, and we have an old ontology, and we have supporting documentation. And as I said, throughout the day, you will understand why it's so many different ways that it's presented. You also already heard that the PREMIS editorial committee is the ones who are coordinating the revisions, not really implementing the standard, but implementing the revisions into the standard, because the implementation is done by everybody, all of you listening to us now, and others implementing and using the standards. We do have a mailing list being the PIG forum, so PREMIS implementators groups forum, and you send an email message to the listserv at listserv.loc.gov with subscribed PIG, and then you put your name, and then you will be a part of that community. And we do preservation metadata workshops at iPress, and we do things like we are meeting you today. The scope for PREMIS is really simple, in my opinion. It's a common data model for how you should organize and think about preservation metadata. We also see it as a standard for exchanging this preservation metadata information between repositories. If I create something for store it, and then for a sudden can't do the preservation anymore, I send it to ELD. ELD needs to know what I've been doing, so I'm also, besides my digital object, also send my preservation metadata to ELD so she can take over the care from me. It needs to be implementable. We do see a lot of things being highly talked about, but not really usable. You need to be able to implement it. And the big thing is that it needs to be technically neutral. You need to be able to present this wherever you want. You need to be able to have a Linux system. You need to be able to have a Windows system, a strange database of some format, an easy database like an Access database, and the story goes on and on. And it also needs to be the core metadata. You might always need more, but these are the things that you really need. And there, from what we are to what we aren't. You can't go into a shop for software and say, I want a PREMIS system. That's not possible, because you need to have something combining with it. It's not all needed metadata, and that will be most certainly shown to you during today. We are also not handling the life cycle of things outside the repository. There have been increased support for the outside, so you can actually describe physical objects, but we want to be inside the repository, the digital repository, and handle the things there. And it's not a fully developed rights management standard. We are working with the rights and are going to do some changes there, but it's still about the rights regarding the preservation. How do we handle the objects in our repository? And we are not, and I'm going on with what we are not. It's not limited or special for archives and libraries. It's for everybody, as I said in the beginning. And we don't say that you need to use the whole PREMIS. If you have looked at the PREMIS data dictionary, you can see it's rather big. And even if we would like that, if you could implement everything, most certainly we know that you can't. So you need to decide what you do and what you use, following the standard. And you can use it also for checking and the quality of the metadata of the systems you're using, because it ties into the OAS reference model. So it's really a versatile standard. Everyone are free to model the digital landscape, so everybody can use it and should use the high. So you need to use the high level elements, but the deeper we go, the more you can actually add if you need to. So with that, when you are tailoring and investigating how you should use PREMIS, you can actually have evolving metadata. You can add more things, which makes it possible to see we have new technology coming. It comes every day. It's really, really versatile. You can add that. And even if the laws are changing, the legal framework gets updated, you still can use PREMIS. And you also need to look at your solutions. What is your need for your system? Do you have institutional policies saying everything is only allowed to be in 3 copies? Or I'm just using TIFF as the format I'm preserving? So you can really configure it as you wish. And it's also, you can get off the shelf, but then it's incorporated into the systems. So it's just not just PREMIS, it's most likely a whole archival system or preservation system. Or you can build the system yourself, reusing what we have in PREMIS. So with that being the basis and the setting the stage, I'm going to hand over to Micky to continue to tell you about the benefits.
Thank you. And let me share my own screen real quick. There, you should all see it now. Yes.
Yes, we do.
Okay, perfect. So now, after hearing this great introduction to PREMIS, let's talk about why you should use it. What's in it for you, right? What are the benefits of implementing PREMIS? And this is something we already heard in the introduction. PREMIS is often referred to as implementable core preservation metadata. And I think it's a perfect marketing slogan for PREMIS, but what does it actually mean for you? So let's start again with the implementable. It means that it's something that's rigorously defined. There's actually a clear guideline that tells you how you can create PREMIS, how you can manage the metadata and use it, right? Rigorously defined means that it tells you what is mandatory and what is optional, how do the different pieces of information relate to each other, and also gives examples of how you can use it. Most importantly, it's oriented towards automated workflows. We are all dealing with a lot of data. It's information we can't handle manually, so we need to ensure that it can be machine processed to assist our preservation processes in the best possible way. This requires PREMIS, or preservation metadata in general, to be technically neutral. Karin already mentioned this. It means that PREMIS makes no assumption about the systems you use. It doesn't say that you have to use an off-the-shelf system or you have to use a specific software. It actually doesn't mean that you have to use XML or RDF. You could capture PREMIS in any of these formats and ways. You could even, in theory, capture your metadata in a CSV file and map it to the PREMIS semantic entities. So that's for the implementable part. What does the core part mean? The core part means that PREMIS contains what most preservation repositories need to know to preserve digital materials over the long term. Karin already described this a bit, and I will give one example in a minute of how you can make use of this. And lastly, the preservation part. It's preservation metadata. That means that it supports the preservation principles. To come back to the pyramid from Priscilla Kaplan that we saw in the earlier slide, preservation principles are things like viability, renderability, understandability, authenticity, and identity of digital objects. all those are things we want to preserve, and preservation metadata is actually the necessary tool to allow us to do this within our processes. So let's look at two examples for benefits of implementing PREMIS. One is persistent identifiers. Now, we might think that persistent identifiers are something so clear that there's only one way to describe them. But in today's day and age, we all have systems of many kinds that talk to each other within our single institution. So there might be a library catalog, a digital library, an asset management system, a digital preservation system, and we all need to make them talk to each other. And sometimes there might even be a single solution, technical solution, that captures identifiers in a different way in itself. On this slide, we see some examples what that might look like. So we have a clear persistent identifier, HDL handle Galapagos.6754.1. And here we can see 4 completely different examples of how that might be captured within a system, right? Some might capture it in a single string, some might break it down into 2 or even 3 elements. So having all that information talk to each other becomes a little bit like the Tower of Babel situation, where we all say something and mean the same thing, but we don't understand each other. And that's true for anything when it comes to preservation metadata. But in order for the information to be understandable in the long term, we need some kind of exchange consistency in the middle. So in comes PREMIS. PREMIS actually brings this exchange consistency. It can be seen as a lingua franca that is actually maps to all the different solutions to make the identifier in that example understandable. PREMIS has a clear way in the data dictionary that tells you how you should describe identifiers broken down into a type and a value. So here we have 2 examples, what that could look like in an implementation, the top in an XML implementation, the bottom one in an RDF implementation. And that can be then mapped to different systems to allow them to talk to each other. And now we have a way that we can actually use the identifier in a persistent manner for the long term because we have a standardized way to capture it. A second example for the benefits of implementing PREMIS comes back to the core information part. Core information, again, says, what do I need to know about a digital object I'm preserving? These are all questions that we ask ourselves on a daily basis as we do digital preservation. And we need to know what we need, or we need to capture what we know today, but also what we need to know in the future to understand that object. So when you sit there and you start to ask yourself questions, you might say, what is the object? What has been done to it? How was it created? With what software and what environment? And what am I even allowed to do with it? Has anything been done before? Like, has the file name been changed? Also, how can you best capture that information? So the other question that you might be asking yourself is, what am I missing? Am I sure that I actually have everything that I need? And is there a good practice? In again comes PREMIS. So PREMIS, as it was stated before, is the de facto standard for preservation metadata. As described in the data dictionary, it is things that most working preservation repositories are likely to need to know in order to support digital preservation. So you can treat PREMIS as much more than just, in parentheses, preservation metadata. It's actually a valuable resource to let you know what you need to capture. Even when starting out with digital preservation, you can take the data dictionary and almost use it like a checklist. You go through the different entities and get good ideas of what it is that you all need for preservation processes. What do you need to know about your objects, events, rights, and agents? It then offers a method for you to model the information that you need to put the different kinds of information in relation to each other. And then a data model with many different implementations. Like Karin said, it's not just for libraries or archives. Any institution, regardless of its size, its type, or where in the world it's located, can use PREMIS. And lastly, it's a community of users with good resources, most of which can be found on the PREMIS implementation website that is linked in the supporting documentation for this presentation, and also with many examples of how PREMIS has been implemented by various institutions. So that should have now totally sold you on why it is that you need to use PREMIS and learn more about it. And Elt will now take over and actually tell you what PREMIS is in much detail. Thank you.
Yes. And this is the same thing you see. What I will do now is that I will introduce you to the data model. And there's a lot in the data model, so I will do it in chunks. First, you will be introduced to the main identities, and then I will relate it to the data dictionary, and then I will go in detail what is actually to be found in the data model and how can you use it. So, the PREMIS data model has three main things. The first thing is the entities. And there's objects, rights, events, and agents, and you will hear much more about that. Then there is the semantic units, and that's actually the things within the entities that you want to express some values about and how they are structured. So it's properties of the entity. And then you have relationships, quite importantly, between the different entities. So what events has been on an object, which agent did the event, what rights are related to an object, etc. And you will hear much more about that as well. So why do we have a data model? Well, it's both to organize this. I think both Karin and Michelle has been talking about actually organizing the data in a structured way that we can understand among each other and also among systems. Then it's a very good framework to distinguish the applicability of the semantic units, the different things that we want in a preservation metadata. And across these different types of entities that represents different parts of our preservation metadata. But it's not a formal, it's very important that you don't see this as a formal entity relationship data model. It's not something you should implement a database from. You should see it as a model that can guide you, and it can be implemented in different ways. I will show example from XML. That's mostly what you will see today, but you can also see it in RDF, and you can also see it used differently in different off-the-shelf tools, but there is a mapping to what it is in PREMIS. So let's dig a bit into what the entities are. The object is what you actually preserve, the file or the representation or the intellectual entity that you preserve. So it's the object you preserve, and as I said, it can be an intellectual entity, a representation in a file, and that may not mean a lot to you now, but I hope that it will do that in half an hour's time. It's different levels to see it. Then as Karin has also said, you don't need to use all of PREMIS, and that also means you don't need to use all these types of objects. If you don't only want to manage the files, you can do that. But if you want the other levels that can give extra information, you can do that. If it repository has more types, you need to record relationships between the types, of course. And examples of objects, that could be a book representation, or a file, or an image within a file. You will have more examples of that later as well. The events, that's aggregated metadata about the actions that happens on the objects. So an action can impact what impact has there been on the object, who has edited it, has it been have you tried to make a format migration or identity on it. It helps to document the digital provenance of what has happened to the object, especially with migration. That's a very important information. It could also be other things which is not changing the object, but so you know what has actually been of events on the object during object's life cycle. Determine which events are in the scope is up to the repository. So it may be that you also want to record if the person has read it or anything like that, but that would be very detailed. But it can also be that you choose in your policy to say, no, it's only things that has changed the object, or it has changed media or something like that you want to register. That's fully up to you. And also the granularity of how much information you put to the events, that's also up to you. And examples of events are Zierau for verifying a file, that it is a PDF file, or it can be a transform from a zip to an AIP in OIS terms. Okay, agents. That's the thing or the person doing something in relation to an event or an object. Can also be in relation to rights. So it's very it can be 4 different things. It can either be a person or an organization, or it can be software system, or it can be a program. So I think there was we will come back to that, but there are actually recommended values for that, so you will see that. And it's intended to identify what program actually did the migration, or which person actually did a change, or looked in it, or what the event was. And it's not that PREMIS say that you have to use PREMIS in a certain way here. As you will see, you can always use other schemes to include in PREMIS, so you can have extracts from tools, or you can base it on other standards, but you will see more about that. Examples, that's John Smith, a person, I will see organization, or Zierau program, which is a software program. Lastly, rights. So that's permission, and as Karin said, it's only rights related to the preservation part. It's not the full right system that you have in your access system. It's only to do with preservation. And that's to say a person can have granted permissions to do actions on the object. It's not a full rights expansion language. You can either choose some things that are in PREMIS, you will see that later, or you can use your own. And a basis for the rights, if you use the PREMIS part, is copyright license, statute, or other. And here are examples. Helen Smith grants FCLA digital repository permissions to make free copies of a certain file. Okay, that was the entities. Now we look at the semantic units. And as I said before, semantic units are something you want to know about the entity. It's a piece of information that you want to put into your PREMIS and to preserve with your digital preservation. There are 2 kinds of semantic units. There's either a container, and you can think of a bag, or there are components which have actual values, which you can put down in the bag, but you can also put other bags down in the bag. So it's the bag contents concept we're using here. So container or semantic components, and I may just say components when we carry on. Just for an example, the object has, of course, an identifier, and you will see more details about that later, but just look at how do we actually specify an identifier in PREMIS. And that's actually by a container, because we need two things for an identifier. We need to know which type of identifier we have and the actual value of the identifier. So how is this expressed in the data dictionary? The data dictionary has a lot of different things. There is actually a background section, and then there is an introduction to the PREMIS data model. And then there's a PREMIS data dictionary, which I will speak a lot about, but there's also special topics, which could be, for instance, environments, which I will talk a bit about as well. But let's start with the data dictionary. So again, if we go back to our example with the object identifier, which has a container and the two components, that is actually expressed by the object has all these different semantic units on the second level. And the top one is the object identifier, which has semantic units on the second level, which is the type and the value. Actually, that is structured by numbers within the data dictionary. So what you see, object is the 1, and then the first semantic unit object identifier is 1, 1, and on the next level it will be 1, 1, 1 and 1, 1, 2. So straightforward. And here is an example where I have actually taken an image of what is in the data dictionary, where here you see section 1.1 with the object identifier, and you could go down with more specific description of the type and the value on these, but it says that this semantic unit object identifier has these components. It also says that this is an object, and therefore you will know, you will have more explanation of it later, but we have these different types of objects. So it can be relevant for different types of objects, whether it's a file or whether it's an intellectual entity. Therefore, this is split into the different types. So intellectual entity and representation has we have merged together because they are always the same regarding these things. And then we have file and bitstream. It says whether it's repeatable. So here you see it is on for all of the types. It's repeatable. That means you can have multiple object identifiers in your PREMIS. It also says whether it's mandatory or optional. And you can see I put some short abbreviations for them here. And that's because you can also look in the list before all these tables. You can see it indicated here whether they are repeatable or mandatory. So you don't have to go down to the tables themselves if that's all you want to need to know. Okay. So let's take this example again with the object identifier. And again, let me say this is an XML example. It's not the same as you need to use XML. It can be RDF or it can be something totally different. But in my organization, we use XML, so that's what I'm most used to. If you don't know XML, don't get scared of these XML examples, because it's just examples for ones that have to implement it, and it can give a better understanding when you see how it's implemented. So in the XML, you have on the outer level, you have PREMIS. On the inner level, you have the 4 entities. We want the object identifier, so that's within the object. And in this case, it has type file. And you have the identifier in here. You have a lot of other stuff also, but we're only looking at the identifier. And then you have the object identifier type as a tag, and in there you have your actual value, because that was a component, so that has a value. And the same thing for the identifier value. Right. As you see here, it is only the object that has these many semantic units. And you have had a long introduction now, and you have had the top level of the data model. So I will continue describing these after having a small break. Take some water, stretch your legs, whatever. We will be back in 5 minutes. So we have the 4 semantic units. Now I will go, the 4 entities, sorry. And now we will see on the semantic units for each of these entities. We start with the object. And what are the semantic units for the objects? That's what kind of object is it? It's software and hardware used to handle the object, where it's stored, or technical information. Which characteristics do you want to preserve in it, and which preservation strategy do you have for it, and other things as well. And that's what I will go through now. And you can see for each of the parts what can be in it. So we start by looking at what is mandatory for an object. And that is actually the identifier, of course. We need to be able to identify our object. And then it's an object category, which is a type of object, which is what I will explain now. There are 4 values. There's intellectual entity, and you should be careful with how you use that word, because in Ferber, intellectual entity has 1 meaning. I used to call this a digital intellectual entity, because it does have a slightly different meaning here, because it does relate to its. Do I have my presentation on? It's just because I see you, Grockowski. so if you can just.
You're online. You're online. Your presentation is visible for everybody, and you in the small window.
Right. Good. Then there's a representation of an intellectual entity, and that's because you have this digital object on the very high level, and then you can have different representation. You will have examples in a minute. And then you have files, but it may also be that you want to take a part of a file, and that will be a bit stream. So this is the only thing that is not implemented as a tag in the XML. Again, remember, it doesn't have to be XML, but if you use XML, this is the only thing that's not a tag. It will be an excite type, and here you see the object is a type file. So let's look a bit more on the intellectual entity. It's a literary work, but not in the Ferber sense. It's what you the object that you actually want to preserve, but it wouldn't be, for instance, if it was a history, it wouldn't be a theater history or theater representation, and the book itself. It would rarely be used as that, but more as to say this is a book. This is the intellectual entity for these digital representations of my book. Then you have the files, and you can see you will have a book example in a minute, because yeah, file, that's just a sequence of bytes. So there's no more to that. And here you see an example where you have page 1 and a page 2, or you have a book file. Bit streams, it's just the same as files, so I won't have examples of that. It's just pointing to a bit stream within a file instead of a file. And then we have the different representations, and here you can see one representation could be the 2 images of pages, and another representation could be books. And you will see it more here. We have a book object, which is our intellectual entity. We have a representation of the original TIFF files that was scanned from the book, in this case. And in this representation, that will point to the two files, but it will be with PREMIS metadata for each of the files pointing to the files themselves. And then it could be that the other representation that is an ebook is actually a derived ebook from the TIFF images. So that's a derived representation which has PREMIS metadata for the actually ebook file itself. So intellectual entity, representation, file, or bitstream. So in this case, it's not a bitstream, but it will just point to a bitstream if it had been. So that was the mandatory part of the object. Now, if we look at the specific characteristics, that is in the container object characteristics. And that's technical properties, and it's usually the properties that you have for files. It's mandatory for files, but and bitstreams, of course. But it could also be that you want to use some of it for your representation and intellectual entities. If we look at file as a named sequence of bytes, it can be 0 bytes, it doesn't have to be more bytes. If a file has a file format, it has some characteristics that you can look up in the file system, like size, and there can be some modification dates, etc. And here you see the sub semantic units for the object characteristics. So this is a second level. You have a composition level here, and I will just explain that first, and then we'll go to the rest. A composition level is because when you get something into your archive, it could be as a zip or a compressed, a gzip file where you have more files in it. So here you have a file which is actually part of something that has been zipped into a gzip file. In that case, you actually want to give information both of the file itself and of the gzip file. But how to do that? Could, if you want other examples, it doesn't have to be a gzip file. It can also be mails with attachments or images within PDFs, etc. But you want to be able to give the preservation metadata for each of them. And therefore you need an indicator to say how does it fit into the bundling and decoding of it. And the solution here is composition level. So we treat each of the levels, because there could be more. It could be a file, gzip, encrypted, or another gzip. So there can be more levels. And what we do is that we have the innermost level that will always be composition level 0. So that means if you only have single files without anything in it, you will always have composition level 0. And then the gzip would be composition level 1, etc. So that is why we have the composition level within it. Fixity, that gives itself. That's a checksum for the file. If you want to do that, I won't go into detail to that because that would be a lot of details. Then the size, that would be the size of the file. and that also is also quite simple. Then there's a format. You will see Michelle give a example later. I will not go into detail here because it's not too complex either. Creating application, that is, if you know the application that actually created it for Photoshop application or something like that, you can put that in here. Inhabitors, that's if you have encryption of your file, you can put that in here. And then we have something called object characteristic extension. And every time you see a semantic unit called extension, that will be the same principle as I explained to you now. Because that's why, that's the way PREMIS is actually opening up to include other kinds of formats. It's actually, I will here show you an example where you can take mix. Mix is a standard for metadata to still images, and you would probably want to have that. If you have your mix metadata, you would want to put that into PREMIS as well. And here you have an example. It's object, file, characteristic, and then there's a lot of other things, but we can come down to the object characteristic extension. You put in your mix data here. And that can be other standards, of course, for other types of formats. And that's also why it's not format specific. You can use any other standard. It has to be XML if you use XML, but again, you can also use other things. Right. That was the specific characteristic. Then we have some more general information about the object. There is significant properties. We haven't seen it used much, but if you want to register, for instance, that you want the rights and preserved for image or something like that, you can formulate your significant properties and put that into here. I'll come back to preservation level because that's a little more tricky. But you can also put the original name in. That's also very simple, single tag, where you, if it had an original file name or something like that, you can put that into that tag. Storage depends on your policy if you want to put in storage here, because if it's static preservation metadata, you should be careful with putting in storage because storage has a tendency to change. But if it's preservation metadata that you have where it can actually have new versions or change, then you can put in here where your file actually is stored. And signature information, that is, if you have some signature information at ingest, you can put them in here. But look, let's look a bit on the preservation level. It's a kind of strategy for your repository that will register here. So that's a bit different than a lot of the other informations that is in PREMIS. It is that you can actually put in the levels you have for your preservation, and I will give some examples in a minute. We use it a lot in Denmark to give different or to state different policies we have for this individual objects. So it's a business rule only relevant for the given repository. It's not something like Karin said, if she sends something to me, it's not that I should use her preservation level because she has one. That's what she used in her repository. What it has, that it has a preservation level type, and there can be preservation levels on different of different types, because we both have the logical level and we have the byte level or the bit level. The bits are the bit level is so we are sure that it's the same sequence of bits and they are not changing over time, while the logical level is that we can actually interpret the bits over time. So the value, for instance, for logical level, that could be emulation, and here is an example, migration, because that's what you do to your object, or that's a strategy you have in order to make your object interpretable in the future. And the bit safety, yeah, well, that's how many copies do you have, how often do you check it, and that can define, which is something you should define within the organization as well. What do you mean by high? But it can be high or very high or low. These are just examples of the values we use in Denmark. You can use any values, define your own levels as you wish. So they are just examples. Then, of course, when you register a preservation level, you should also register the date it was assigned. So that component is there as well. And then you have opportunity to put in a rationale. Maybe it's that it's getting a high bit safety, even though it should be low, but it's because of some a specific reason. Then you could put that into a rationale. And then there's a role. Is this attended preservation level, or is it is it a requirement or whatever? But these are optional, you don't need to use them. So that was the preservation level.
There was actually a question in the Q&A here.
Yeah.
Is there any dictionary that should be used for creating application and object characteristics?
Is there any dictionary?
Yes, controlled vocabulary, I think.
Yeah, I can't by head remember where there are values for controlled vocabulary, but in the data dictionary there are links to vocabularies where there are made vocabularies. So I don't think that is for the creating application. And also remember what it does in the data dictionary, when it points to a vocabulary, it will be the ones that we have made for PREMIS, which is in Library of Congress, id.loc.gov. But there can also be other registries that you can refer to. So it's not that you have to use them. It's a guideline where you can take them from. So if you can look at the data dictionary if it's there, and if it's not, you can make your own or refer to something else. I hope that was question enough. Otherwise, please put it into the question and answers.
I have copied it to a file that we share.
Okay, good. Yes. So, and fine, Micky, just interrupt me again in this way after a chunk. That would be very good. Environments is a bit special, and I don't think we are there to explain a lot about environments just yet, but I will come back to it when we have introduced the other things. But I will talk a bit about the linking, and that's what you see here. You should notice the linking event identifier and the linking write statements identifier, because that's actually something that links to event and write statements. And that's in general, when you see these arrows between the entities, at least these four, what they are is that actually semantic units on the different entities where the object you just saw, it has a linking right statements identifier and the linking events identifier representing these direction of the arrows. And the same way event will have this direction and pointing to agent, etc., etc. So it's the same for the different entities. So the component of such identifiers are again types and values. Although there are in some cases exceptions where you can also define a role, for instance, for an event, because the same agent may be have a different role in the digital archive system. So therefore, you want to put a role in, or you have a possibility to put a role in. But otherwise, they look like this, all of them. Okay. Then there is a relationship, and the relationship is actually the arrow pointing from object to object, because there we cannot just have a semantic unit. We need actually a semantic unit that makes a relationship. So the reason we need between objects is that we have these different types of objects. For instance, an intellectual entity can be a part of another intellectual entity, the same for representation, file, and bit stream. We also have that a bit stream can be included in a file. We also have that a file can be included in a representation. So that's other examples of relations. And we have that a bit stream can represent an intellectual entity, a file can represent an intellectual entity, and a representation can represent an intellectual entity. So we need to be able to actually express these arrows as relations. And if you look in the data dictionary, it's the same thing. It's just drawn a bit differently. So that would be this one you would look for. Right. So if we take an example, so if we have a representation that points up to an intellectual entity, it will be a structural type of relation. And it will be the representation represents the intellectual entity. And then it will so it will be on the representation object, and it will have with this relation, it will point to the intellectual entity by the identifier of the intellectual entity object. And within this identifier, again, you have a type and a value. You also have a sequence if that is needed, but that's optional. Objects, they can be associated with events in two ways. You already saw one way where the event points to the object or the object points to the event. But there's one case where we also need to use this relation for the kinds of for relations between objects and events. And that is when you have migration, because a migration is from one object to another. So in that this case, you will have that relation between the two objects, and you will point to the migration event by this identifier. And otherwise, you use the linking event identifier, as we saw before. Okay. The last two is again environment, and we are waiting a bit with that. So now we have seen the objects, entity, semantic units, and we are missing a bit here about environments, but we will take that later. We have the rest of them here. How long do we have we gone here? Yeah, it is half an hour. because I don't know. I think we should take some questions here. I thought this would take a bit longer, but it is a lot to take in. So that's why I put in a 5 minutes break just to take it in. So then we will go back with the other entities.
And we have 2 questions that we can potentially start with from the Google Doc. Elle, do you want me to read them? One is, can one representation be shared between several IEs? For example, several websites captured within one web crawl. How to handle this situation if I want these websites to be taken as separate IEs?
Well, the thing about identifiers is related to how you actually want to model it. If you have made a web call and have a walk file with all your elements in it, it depends whether you only have the level, want to have preservation metadata on the level of the walk file. But actually a walk file is a container like the zip. So you have each of the files within it, and they have identifiers as well. I think a common misunderstanding is that an identifier is seen from the access point, but it doesn't. You don't need to have all the identifiers you need for the preservation part in your access point. And as soon as you want elements within your walk file, if you want preservation metadata for them, they need an identifier. I hope that answered, and please supply me, Michelle and Karin, if you want to.
Micky. Yeah, I think the sub-question that's still open is if one representation can belong to multiple IEs.
Well, I think that's more a relation. A representation, yeah. Well, if I think you would like to say that's actually a digital intellectual entity that is belonging in more places. Because if you do something to the file, which is within the representation, or the files within the representation, you don't want to change it all up. Then it explodes. Then you want a higher level to refer to.
And the second question, and Darius kindly shared the screen here. What is the advised way of acquisition of the premise data if you are receiving digitized objects from outside? Should the person creating the digital object provide it, or should it be up to the organization preserving the object to acquire the data?
I think that's what agreement you have. We have, for instance, when we have digitized materials by a third party, we ask them to collect preservation metadata, because that's a time where you actually have it. When was it created? Who created it? What software created it? All these stuff can only be done by the one creating the object. But it is, of course, something that you have to have in agreement. I think in many cases we have the problem that people say, well, you get something in, then you preserve it. But actually, it's starting much earlier. So it's a good question, because it does pay attention to that. Sometimes you actually need to have some information from the one providing the object.
Thank you.
Okay, so let's continue the presentation.
Yes. So we were still missing the 3 remaining entities.
Okay, so you should share your screen again if you like, because I interrupted you. Sorry.
That's a fact.
Questions?
That's fine. Yes, that was it. Yes. So we we are missing the 3 remaining entities, and we start with the event entity. And you can see here the different semantic units for it. And it has actually 3 semantic units that are mandatory. It both have to be identified, but it also has a type, what kind of event, and when the event was created. So what you can say, an event can't exist on itself. It must be related to one or more objects. Otherwise, it doesn't make sense. But you can relate it to one or more agents. For instance, the software doing something, and which is actually part of the event. But you don't have to. Right. So, identifier. That's what you have seen before. Type, value, and again, linking agent identifier, linking object identifier. That's when you point to an object or an agent, as in the big diagram. Totally the same way as for the object. Date. That's just the date. There's nothing very complex about that. But the type, we ought to look more into the type. The types, here you see a wide range of different examples of types. It can be indigestion, it can be validation, it can be virus checking, etc., etc. It's a value saying what kind of event is this about. And here we actually have a link to a controlled vocabulary. So again, it's suggested, or it's good to use those values, because then you can point to this vocabulary and others will understand that. We do update it now and again, because we do sometimes find out that they are missing some types. Recently, I found out actually when they did digitizing outside, there were some of the events that they did which were not represented as type in the vocabulary. So you have to document that in another way. Right. So you could also use coded values and the granularity, because there are also very different granularity also in the controlled vocabulary. But that is implementation specific. That's you who decide what granularity you want. And it's just this single value, so there's nothing more to it. Then there's detailed information, because sometimes the events create or it's detailed information about what event it is. So it's additional information about the event. It doesn't need to be machine processable. It could also be structured to allow it. So what it contains is event detail. And again, you see here event detail extension, where you can put in whatever you want from another scheme. So an example is this code, which is an agent requesting designation. So it's different codes for what this event was that gives meaning to you within your system. An outcome, that is that, for instance, a validation event that can come with an outcome from the event, and you may want to store that with the event. What is the outcome? You will also see an example later that Micky will show you from where we actually have this event and using this. So it's structured. It can be codes, 0 for meaning okay, for instance. or it can be a detail with a note. And again, this extension where you could actually, if it was a standardized format from, or just a XML formats, for instance, from the pitch tool, you can put it in here in that form, pointing to the fit scheme. Right. So that was all for the event. Now we can go to the agent. The agent has a bit more. And the only mandatory semantic unit here is that you should be able to identify your agent. Then there's, it may hold or grant one or more rights, or it may carry out, authorize, or compel one or one or more events. And it may create or act upon one or more objects through an event with respect to the right statement. So that's where you get the rights in as well. And you will see more also with the environment later. Identifier, that's the usual thing, the type, value. Agent extension, again, you can take another scheme, put in here if you want it described in another way. Linking event identifier, that was where we have the pointers for each of the entities to each other. So it's linking to event and to write statements. Then we have the name. It's just if you want to give it a name, you can do that. Then there's the version. That's also just a component where you can put in the version, and a note, that's also just a component where you can put in a text string. Well, linking identifier, environment identifier, again, we take that with the environments later. And agent type, that's the four I was mentioning before. It can be hardware, it can be organization, it can be person, or it can be software that is actually carrying out an event. And again, we have a controlled vocabulary for these, and that's one of the places where you should use one of these. Right, that was agent. Now we only have rights back. Before we go to the environment. A right statement, a right can either be a right statement or a right extension. One of these must be present when you do a right. And it should be, if you have a right statement, you shouldn't have a right statement extension also, then you should split it in two. So it's one of these. Rights extension, that's if you want to put all your rights metadata in another scheme as for all the other extensions. Where right statements is a specific way to do it within PREMIS. And that has a lot of different semantic units. It of course has an identifier, again, type, value, and it can link to object and agent, again, what you saw before with how the entities link to each other. And then we have these remaining information which actually describe the rights statement. We have the basis, which can either be copyright, statute, license, and other. And what you have is that it's either of these. So if you have the right basis is copyright, then you fill in the copyright information semantic unit. So that's how it works. So if you see here, you have the right basis, and then it's one of these that you actually use, the four of them. and if more than one of these bases applies, then you should make a full new rights entity beside it. So an example of right basis for copyright information is that it has status copyrighted, copyright jurisdiction, that's us, or US. I'm sure it's US. Copyrights the dissemination date, which we put here. There can be a note, and there can also be a link. So that's what is within the copyright information semantic unit. And likewise for the license statute and other rights information, there are also semantic units in the same way as for the copyright information. So now we are only missing rights granted. And that is what is action, what action is actually allowed, under what condition, and are there actual time restraints for the rights granted. It contains act and restriction. Act that can be migrate or modify. It could use a event type value, as we saw it before. And restriction, that's a description of the condition or the limitation on the act. And then there's a term of the grant. So that's a start date and the end date, if they are both, otherwise just give one, for the actual rights granted. Then there's a term of restriction, and there again you have the start and the end date. And then you can also put a note to it. So that was all of the 4 entities without environments. And environments is, it's not too complex, but it is a bit complex. So take a deep breath and we will dive into environments. There's not an entity called environment. We were actually discussing that when the environments were introduced in version 3 of PREMIS. But the thing is that an environment is an object in itself and can be on the intellectual entity level, but it can also be on a file level. So therefore, objects are environments are actually described as object. So it's actually in here. It can also be both a content object. You can think of, for instance, installation file. That can be something you want to preserve as a file, but at the same time, it can be part of an environment. So it can be part of both. And that's actually why you have this, because an environment can actually be the agent. So that's why you have this relation. But you will see that in a minute also. What is needed to render and use a content object? That's why we actually introduce the environment, especially with emulation. That's quite relevant. But it's also relevant in order to document your object, how you can actually interpret it. So it's a part of the logical preservation. How can I actually interpret my bits and get meaning out of them? And for most objects, you need an operating system like Windows, and application software. If the Word file could be Word. And you need some hardware because it has some constraints on what it can run on this application, and the computing resources. So if you have an environment stack, you have some dependency relationships. For instance, a file it requires the software application, the word, in order to be rendered. But the software application has to also requires a software library and also an operating system, which also the software library will require. And again, that requires a specific hardware architecture to run on. So these are all objects that which has this relationship that they are requiring each other in order for the file to be rendered. So here you have a relationship type dependency, and a subtype requires, as you saw it with relations previously, so you can see where I'm getting at. We're getting back to a relation. We also have another type of relation because, as I said before, actually the file content object that can be is represented, as we saw before, by intellectual entity, but it requires intellectual entity for the hardware and for the operating system and for the software application. But the operating system can be an ISO image, a file itself. So here you have the thing that actually the components here of the environments are files and intellectual entities themselves. They are all objects. And the same for the software application, that could be the executable file. Let me again stress that you are the one who choose what levels you take in and what granularity you use and which files you actually have here. So if we are going to these semantic units that I left out before, because I said, let's wait to the environment, we have this linking environment identifier in the agent. And that is, as I said before, an agent is an actual environment. That could be the word program, for instance, where you render something in. So therefore, you need to say that this agent, that is software, but it's actually this object we are talking about, which are the agent. That's why we have this extra semantic unit linking environment identifier, where environment is the object for the environment. Right. Then if we look at that was the age, this relation. If we look at the object, we have several semantic units where relationship is one of them, and then we have some extra. I think we start with the again, we have the extension, of course. You've seen that many times, so you can put in extra information in another format if you want to do that. Environment function, that is software level 1, just to take you put in, or operating system level 2. The environment designation, that could be Windows XP Professional, for instance. And you could also have a registry for instance, software, where you have a link to an external registry. And then we have the relationship as we saw before, and we have the dependency requires, because you have already seen the ones where it represents. That is it's the same as for any other objects, but specifically for environments, we have this relationship type dependency and subtype requires. So let's look a bit on what kind of relationships we have between objects and environment objects. there's actually different types. First, you have object to environment. So this is an object which is not an environment, but it has a relationship to an environment. For instance, that you can render the object by that. So that is from the object to the environment. It could also be environment to the object, because it can be that you have documentation of the environment as a file that you also preserve. And then the environment should be able to say, this is the documentation for me. So that is the other way around, from the environment to an object, for instance, with a description. And then you have from environment to from environment to another environment. That can be inclusion, dependency, derivation, and other. And also the required one, as you saw before. So that was the relationship types you saw, but we also had these extra semantic units saying related environment purpose and related environment characteristics. Environment purpose could be create or edit or modify, and with the word example, it could be render. You can actually see your file. And the characteristic could be that it's unspecified. You don't know whether it's a minimum, or just know it to work, or it's recommended that you use this environment to, for instance, render your file. So that's more about how the object, because if you have a Word file, it may be that you can use another version of a Word, a later version, but you cannot be sure how it looks in that. So therefore, maybe it's a recommended because you know it works, and then it would be known to work, or it could be recommended because you know that that is actually the version that you should use. So that was the two semantic units for relationship related to environments.
Oh, there's one question about environments. Sorry if I make
Yes.
it in right now. It's actually if we are aware if the Internet Archive is using environments to describe software archive or and emulation dependencies.
There are different initiatives for software environments. There are also the Micky, or I don't remember the word right now. There are different initiatives around the world, and we also have the challenge that we are not all, as libraries and archives, allowed to actually preserve the executational code. So that's why there are these different initiatives, and that's also why you may want to point to a registry. But yes, we are quite aware of all the different, at least in my institution. But in this context with preservation metadata, it's of course important to be aware of these initiatives. But it's up to you to find out what is your legal framework to what you can actually preserve and what you should link to instead out in the world. I hope that was answer enough. Otherwise, there will be possibilities to ask more in the end of it. You can see I have 10 minutes left, but we are almost there, so it may be that we can open for some more questions. Again, for environment purpose, there is a controlled vocabulary that you can use or get inspired from. I was actually completed. So if there are any more questions, I gladly try to answer them. the best I can.
You can also place questions straight into questions and answers module in Microsoft Teams. Of course, you can also use the shared file. I'm trying to copy the questions from the shared file to questions session in Teams so that it will be long time preserved.
Yeah, okay. Is there any more questions here now? Otherwise, sorry?
I cannot see any more questions now.
No, okay. What we can also do is that, because the next slide is actually back 12:30, that was maybe a bit optimistic slide, because that would mean that I stopped exactly at 12 o'clock. So we could say that we are back 12:25, and we can see if some more questions has come. And if there are, we can use the first 5 minutes to answer these questions.